Okay then. So in this module we are going to cover locomotion and movement. Okay Trisha, let's start then. So in this module we are going to cover locomotion and movement. So before starting I need to tell you that what are the topics from which the maximum questions are asked. So the topics are, first it is the skeletal muscle contraction mechanism. Then the other topic, it is on the joints, and then apart from that it is about the skeletal system, the axial and the appendicular skeletal system. So based on these topics only you will get at least 60 to 70% of the question. So try to make your concepts clear on these topics. Okay, so let us start. So starting with question number 1, which of the following is not a function of the skeletal system? Option A, locomotion, B, production of erythrocyte, C, storage of minerals, and D, production of body heat. So what is not the function of the skeletal system? So the main purpose of the skeletal system that we all know is the locomotion. It is the primary thing for which the skeletal system was formed, isn't it? But apart from that, with evolution, the certain functions were taken up by the skeletal system, and that function include the production of the erythrocyte. Where the production of the erythrocytes occur? It's occur in the bone marrow. The amount of bone marrow is very large, very high in the babies, but as we grow, then the amount of bone marrow decreases gradually. So option B is also correct, and the C is storage of the minerals. And what is the form of mineral in which the minerals are stored? So the storage form of the mineral in the bone, it is the calcium hydroxy apatite. So it is the form in which the minerals are stored. So the only odd one out option here is option D. The skeletal system doesn't produce heat at all. Yes, Trisha, very well said. It is option D. Now coming to question number 2. Characteristic of smooth muscle fibers are: option A, spindle shaped, unbranched, unstriated, uninucleate, and involuntary. Option B, spindle shaped, unbranched, unstriated, multinucleated, and involuntary. Option C, cylindrical, unbranched, unstriped, multinucleated, and involuntary. And option D, cylindrical, unbranched, striated, multinucleated, and voluntary. So these are the 4 options. So see, the muscles are classified based on various characteristic, isn't it? And they are based on the control. See, whether you can move the muscle or not, based on that the muscles have been divided into voluntary or involuntary. Then based on the striation, it is whether the muscles are striated or non-striated. Then based upon the nucleus, it is uninucleate or the multinucleate. And the other thing is shape, that is not the primary thing. So if you can name a muscle or identify a muscle based on these properties, then it is more than enough. So Trisha is saying it's option D. So let us see. We will discuss 3 types of muscles in the following heading. The first one is the smooth muscle. The smooth muscle is a spindle shaped muscle. What do you mean by spindle shaped? Spindle means S shaped. So this is the spindle shape. So this is spindle shaped muscle, and it is unbranched. It is not branched, and it is non-striated. It means that there are no striations present over here. And apart from that, the smooth muscles makes up most of the gut, like your intestine, okay, your urinary bladder. All these things contain the smooth muscles, and they contract on their own, and they are in control of the autonomic nervous system. So they are involuntary. You cannot make your gut contract by just thinking, okay. And the nucleus type is a single nucleus, that is a single central globular nucleus that is present in the smooth muscle. So the correct answer is option. Alright Trisha, but let us cover the skeletal muscle and the cardiac muscle as well. So what do you mean by skeletal muscle? The skeletal muscle, unlike the smooth muscle, is a cylindrical muscle. It means strip, like you can see on the tiger. Okay, the strips are present, and it is a voluntary muscle. See, like you can contract your biceps. Okay, if you can contract this bicep on your own, it means that it is a voluntary muscle. And I told you that it is a striated muscle. And the nucleus, there are various nucleus present in this muscle, and that is why it is a multinucleate cell. Okay, this is the multinucleated muscle, and this multinucleation is also known as the syncytium. Okay, syncytium. And the last type of muscle that we will be discussing is the cardiac muscle. The cardiac muscle, it has the properties of both the smooth muscle as well as the skeletal muscle. The property that is shared similar to the skeletal muscle is the striation. So it is striated. It is the cardiac muscle. So it is striated. But you know that you cannot control your heart on your own, and that is why it is an involuntary muscle. And the other thing is that it is a single nucleated, and it is a branched. That is a special quality of the cardiac muscle. So I hope it is clear to all. All right. Now moving on to question number 3. Out of X pairs of ribs in humans, only Y pairs are the true ribs. Select the option that correctly represents the value of X and the value of Y, and also give the explanation that is relevant to the question. So option A, so X is the total number of ribs that is present in human beings, and Y is the total number of true ribs. So in the exams, false ribs and the true ribs are frequently asked. Okay, false ribs and true ribs and the floating ribs. So see, X is saying it is to be 12 and Y is 5, and it is saying that two ribs are attached dorsally to the vertebral column and sternum on the two ends. Option B is saying that there are totally 24 ribs and there are 7 pairs of true ribs. Option C is saying that, yes Jivita, you are saying it is option D. Let's see. So option C is X equal to 24 and Y equal to 12, and option D is X equal to 12 and Y equal to 7. So see, in the examination you need to do the question in the minimum amount of time. So as you can see that in A, B, C and D, the value of X and Y is different in all the options, isn't it? And that is why there is no sense in reading the other part of the question, because you can just point out the option based on A, B, C and D based on X and Y. So let us talk about the types of ribs. So there are 3 types of ribs that is present in the human beings. And what are they? See, the first pair of kind of ribs is known as the true rib. And what do we mean by true ribs? See, the back part of the body of human body is known as the dorsal part, and the front part is known as the ventral part, and the heart is present ventrally. So how the rib arises? It arises dorsally from the vertebral column. Okay, and it is bicephalic, just to know. Okay, and then it comes to the front and then it attaches to the sternum, and this is how it has to go, and the other pair of rib from this side. So the ribs that comes from the vertebra and attaches to the sternum, they are known as the true ribs. And how many such ribs are there? They are 7 in number. So true ribs Y equal to 7, and the total number of ribs that are present in the human beings, they are 12 pairs of ribs. And what do you mean by the false ribs? So of these 12 ribs, the ribs number 8, 9 and 12, 8, 9 and 10, they do not attach to the sternum. They do not attach to the sternum. Instead, they attach to the hyaline cartilage. Okay, the ribs to the sternum attaches via the hyaline cartilage. It is also important. So the 8, 9 and 10 ribs, they attach to the hyaline cartilage of the 7th rib, and that is why they are known as the false rib. And coming to the floating ribs, they are the ribs number 11th and 12th pair. They do not attach to any of the ribs or the sternum, and that is why they are floating. Okay, and that is why they are known as the floating ribs. So the correct answer, as you all said, is option D, X equal to 12 and Y equal to 7. Now coming to question number 4. Glenoid cavity articulates with. What is the glenoid cavity? Option A, scapula with the acromion, option B, clavicle with the scapula, option C, humerus with the scapula, and option D, clavicle with the acromion. See, first of all, we need to know that what is actually the glenoid cavity. All right. So see, we have two type of girdles, and that is the pectoral girdle and the pelvic girdle. We have two type of skeleton. One is the axial skeleton. Okay, from head to toe, that you can see it is the axial skeleton, the skull, the ribs, the vertebra. Okay, that is the axial skeleton. And the periphery part like the hands, the legs. Okay, these are the appendicular skeleton. So these two are two different things, and the point where the appendicular skeleton attaches with the axial skeleton, that is known as the girdle. Okay, so the upper limb is attached to the axial skeleton with the with the pectoral girdle. Okay, this is the pectoral girdle, whereas the lower limb is attached via the pelvic girdle. So this scapula and acromion or the glenoid cavity is a part of the pectoral girdle. So the pectoral girdle has the scapula and the clavicle. The scapula, it has a cavity, and this cavity is known as the glenoid cavity. And in this cavity, a ball like humerus. So this is the glenoid cavity, it is the humerus. At the front, it is like a ball, it goes inside. Okay, and that is why the glenoid cavity, it articulates scapula with the humerus. So the correct answer is option C. And the important question other than this is that what is the type of joint that is seen over here? It is the ball and socket type of joint. It is also asked in the examination. Yes, Jivita, it is option C. Now coming to question number 5. Which of the following joints would allow no movement at all? See, what do you mean by joint? Joint is the connection between two bones, or a bone and a cartilage. So that connection is known as a joint. So there are some kind of joint that do not allow any kind of movement, and what are they? Option A, cartilaginous joint, option B, synovial joint, option C, ball and socket joint, and option D, fibrous joint. So see, there are three types of joint. Okay, Trisha, you are saying that it is option D. Okay, let us see. See, there are three types of joint. One is the fibrous joint. Okay, one is the fibrous joint, other is the cartilaginous joint, and the other one is the synovial joint. Joint number 1, then 2, and then the 3. See, fibrous joint is the one in which there is no movement at all. It is like a fiber. Okay, everything is fibrosed. They do not allow any kind of movement. And what is the area in which you do not want any kind of movement? Is it the skull or not? Yes. See, you do not want that when you press the head that the skull bone should move, because then your brain will be smashed, isn't it? And that is why no movement is allowed here, and hence it is seen in the flat skull bone, that is the fibrous joint. Then the other thing is the cartilaginous joint. In the vertebra you want little movement, okay, like you have to bend for doing some task, and that is why we need a cartilaginous joint, and it is present in the adjacent vertebra in the intervertebral disc. And the third joint, like in the hand, okay, here you want a complete motion of the movement, because this is essential for the locomotion, and hence this type of joint where the movement is maximum, it is known as the synovial joint, and it is seen at various regions. So this is the primary classification of the joint, and hence the correct answer is D, fibrous joint, and it is seen in the sutures that is present in the skull bones. Okay, yes Trisha, the answer was option D. Now coming to question number 6. Select the correct matching of the type of joint with the examples in the human skeleton. So again we are going to solve the question based on joint, but it is the secondary classification. Okay, let us see how. Here it is a type of joint and here it is the example. Option A, cartilaginous joint, it is present in between the frontal and parietal. Option B, pivot joint, it is present between third and fourth cervical vertebrae. Option C, hinge joint, it is present in between the humerus and the pectoral girdle. And option D, gliding joint, and it is present in between the carpal. So let us see. So I earlier told you about the classification of the joint. It was into the fibrous, cartilaginous and the synovial joint. But the synovial joint is further divided into various other type, and that is one, ball and socket joint. Other than that, it is the hinge joint, then the pivot joint, then the gliding joint and the saddle joint. So, okay, Akshay, you were saying that it is, okay, Trisha, it is option D. Let us see. I told you that in between the frontal and parietal, they are the skull bones, and in between the skull bones, you want no movement at all because you have to protect the brain. It is its primary function. Joint here is the fibrous joint and not the cartilaginous joint. Now coming to the pivot joint. So what do you mean by pivot joint? Pivot means there is one point and around this point the other part is moving like this. Okay, so where it is present. So see the head, it is moving like this, exactly the pivot movement, and it is present in between the first and second cervical vertebra. And what is the name of first and second cervical vertebra? The name of the first cervical vertebra is the atlas and the second one is the axis. So it is not between the third and fourth, and hence this is also incorrect. Now coming to the hinge joint. Hinge, you can see the hinge in the door. Okay, so see the elbow joint, it is like a door, opening a door, isn't it? And that is why it is present, hinge joint is present in the elbow joint or the knee joint. Okay, so option C is also incorrect. In between the humerus and pectoral girdle, I told you it was the ball and socket joint. So C is also incorrect. So the final and the correct answer is option D. That is the gliding joint. It is present in between the carpal because they are gliding over each other. They are gliding over each other. Correct answer is option D. Yes, as you all have pointed it out correctly. Now coming to question number 7. Question number 7. Select the correct statement with respect to the locomotion in humans. We are talking about humans. Option A, accumulation of uric acid crystals in joints causes their inflammation. Option B, the vertebral column has 10 thoracic vertebra. Option C, the joint between adjacent vertebra is a fibrous joint. And option D, the decreased level of progesterone causes osteoporosis in old people. So these are the three statements and we have to see that which among the following statement is correct. So what is the number of the thoracic vertebrae that is present in the body? The total thoracic vertebrae that is present, it is 12. So option B is incorrect. And the type of joint in between the adjacent vertebrae, what I have told you, what kind of joint it was? Yes, the kind of joint, it was the cartilaginous joint, isn't it? That allows the limited movement. And what is the cause of osteoporosis? What exactly is the osteoporosis? And in whom does it occur? Osteoporosis is a condition that is seen in old female. In females, the estrogen is necessary for making the bone strong, okay, because it helps in mineralization of the bone, the estrogen. But what happens after the menopause? The level of estrogen decreases in the body, and that is why the bone becomes weak. And that is why you have heard that, or you have seen in your family also, that your grandmother is having the frequent problem of back pain, and that back pain is because of osteoporosis, and it is because the estrogen is low in their body, and hence it is not the progesterone, it is the estrogen. So the only correct answer is option A, the accumulation of uric acid crystals. Uric acid is a foreign thing, it should not normally be present in the joint, and if it is present, the body will try to remove that uric acid crystal, and for that it will cause inflammation. It is the natural response of the body. So yes, Trisha, very well said. It is option A. And what is the name of this condition? The name of this condition is known as gout. Now coming to question number 8. Three of the following pairs of the human skeleton parts are correctly matched. Alright. And with their respective skeletal categories, and one pair is not correctly matched. Okay. Identify the non-matching pair. So these are the four options. It is the pair of the skeleton parts and it is the category. So option A is saying that sternum and ribs, they are the part of axial skeleton. Option B is saying that the clavicle and the glenoid cavity, they are the part of the pelvic girdle. Option C says that humerus and the ulna, they are the part of the appendicular skeleton. And option D is saying that the malleus and stapes, they are the part of ear ossicle. So let us see. I told you that all the bones that are present in the straight line in the body, like the skull bone, the vertebra, the sternum, ribs, they are the axial skeleton. So yes, option A is correct. Okay, Trisha, you are saying that it is option B. Okay, let's see. Now coming to the clavicle and the glenoid cavity. Yes, I told you earlier also what type of girdle it is. It is the pectoral girdle and not the pelvic girdle, and hence this statement is incorrect. And yes, humerus and ulna, it is the appendicular skeleton. So see here, this is the humerus, and towards the little finger, this area here, it is the ulna bone, and towards the thumb region, this side, it is the radius bone. Okay, so it is the appendicular skeleton, and malleus and stapes, they are the ear ossicle. Actually there are three pairs of ear ossicle, three on each side, on each ear: malleus, incus and stapes. And stapes is the smallest bone in our body. So yes, Trisha, very well said, it is option B. Now coming to question number 9. Which one of the following is the correct matching of the three items with their grouping category? So option A is saying that ilium, ischium and pubis, they are the part of coxal bones of the pelvic girdle. Option B is saying that actin and myosin and rhodopsin, they are the part of muscle proteins. Option C says cytosine, uracil and thiamine, they are the part of pyrimidines. And option D says malleus, incus and cochlea, they are the part of ear ossicle. So let's see what exactly is the correct option. So I told you that about the pelvic and the pectoral girdle, isn't it? I told you about the bones of the pectoral girdle. Now it's time to see about the pelvic girdle. So this is the pelvic girdle. The pelvic girdle connects the axial skeleton with the lower limb. Okay, that is your leg. And the pelvic girdle contains the coxal bone. And what do you mean by the coxal bone? What is it formed of? Coxal bone is formed from three individual bones, and these bones are known as ilium, ischium and pubis. This is the ilium part, and the frontmost part is the pubis part. And yes, Trisha, very well said. I guess Trisha is studying very well. Okay, very good. See, and the frontmost part is the pubis, and this is the ischium part. Ilium, ischium, and it is the pubis. So yes, these are the part of coxal bone, and it is the part of pelvic girdle. So the correct answer is option A. And similar to the glenoid cavity in the pectoral girdle, there is similar cavity in the pelvic girdle also. And what is that cavity known as? That is known as acetabulum. Alright, so it is the acetabulum. Now talking about the other options also, the actin, myosin, yes, they are the muscle proteins, but this, see this, it is the rhodopsin. Rhodopsin is not a muscle protein, it is the pigment that is present in the retina, and that is why it is not the correct answer. It is not the muscle protein, it is present in the rod cells, isn't it? Coming to the option C, see, all of this option is not the pyrimidine. Okay, one I can tell you that here There are two pyrimidine, but there is one purine. So that's the homework that you have to find it out, which one is which. And talking about option D, so I told you that there is three ossicles, that is malleus, incus and stapes. So yes, malleus is true, incus is true, but not the cochlea. Cochlea is the other name for the inner ear, and hence it is not the ossicle. So option D is also incorrect. So the correct answer is option A. Now coming to question number 10. ATPase enzyme needed for the muscle contraction is located in option A actin, option B troponin, option C myosin, and option D actin. The body, what is the function of our body? Body tries to produce energy. Why we eat food? To produce the energy, because each and every process in the body requires energy. If you try to contract this muscle like this, then also the energy is produced. And how this ATP behaves, or how this ATP acts in the muscle protein, that is the question. So there are two types of proteins that is present in the muscle. One is the actin protein and the other one is the myosin protein. So this is the myosin protein. The myosin protein is just like two snakes that are going together, all right, and this is known as the thick filament, and above that is the actin. Actin is present exactly above this. Okay, this is the actin. It has various kind of proteins: F protein, troponin, tropomyosin. So the tropomyosin, it covers the myosin binding site. So this is the actin binding site on the myosin. Similarly, there is a myosin binding site that is present on the actin. And when the muscle receives a nerve signal, then when the nerve signal reaches this motor end plate, then it will send an electrical signal, and because of that electrical signal, the calcium ions will be released from the endoplasmic reticulum, and then the actin, the myosin binding sites will be released from the actin, and then this myosin will bind to the actin, and here on the myosin there is one other site that is known as the actin binding, the ATP binding site. Here the ATP binds and it helps to attach the myosin to the actin, and then after that it also helps for the contraction. So where option A, when myofilaments slide past each other, the myosin filaments shorten while the actin filaments do not shorten. Option B, when the myofilaments slide past each other, the actin filaments shorter while the myosin filament do not shorter. Option C, actin and myosin, both the filaments shorten and they slide past each other. And option D, actin and the myosin filaments do not shorten but they just slide past each other. So what happens in the contraction of the muscle? The contraction of the muscle was explained by a theory, and that was known as the sliding filament theory. And who gave this theory? This theory was given by scientists, and both of their surnames were Huxley. So they were Huxley and Huxley. So how the contraction occur? So this is the Z line, and on the Z line, this is on the Z line, I will show you. On the Z line, the actin is attached. So it is the actin that is attached on the Z line. And what happens apart from actin, the other protein, that was the myosin. The myosin is sandwiched in between the actin. So this is the myosin. So how the contraction occurs? Contraction occurs because the myosin attaches with the actin. Myosin attaches with the actin, and then it pulls the actin to the center. So final state is that finally it looks like this. So tell me, which one of them shorten? None at all, isn't it? Because they are just coming close to each other and they are not shortening, and hence the correct answer should be option D. Yes, Trisha, it is option D. Now coming to question number 13. The H zone in the skeletal muscle fiber is due to option A, the central gap between the myosin filaments in the A band. Option B, the central gap in between the actin filaments extending through the myosin filaments in the A band. Option C, extension of the myosin filaments in the central portion of the A band. And option D, the absence of the myofibrils in the central portion of the A band. So there are various questions that is coming from the structural portion, that is the structural unit of the muscle. And what is that known as? It is known as the sarcomere, and that is why you need to know in depth about the sarcomere. So let us see. There are the, okay, Trisha is saying that it is option A, that it is in between the myosin filament. Okay, let us see. So see, this is the functional unit of the muscle, and that is known as the sarcomere. The sarcomere is present in between the two Z line. So this is one Z line and this is the another Z line. Okay. Now I told you that to the Z line the actin is attached. So this is actin, and in between the actin, sandwich between the actin, it is the myosin. The actin is known as the thin filament and the myosin is known as the thick filament. Yes, I told you. Now coming to the zones. So the thick filament, the complete area where the myosin is present, it is known as the A band. Okay, see, it is dark and light band, isn't it? So take the second letter, like dark it is A and light it is I. So dark band is known as the A band. A band is the dark band. It is known as the H zone. This is known as the H zone. So now tell me what is the correct answer for this question. So it is the central part of the thick filament. Yes, it is the central part of thick filament, and it is present in between which two filaments? It is present in between the actin filaments, isn't it? And that is why the correct answer would be option B. Okay, the correct answer is it is present in between the actin filaments and it is in the A band. Okay, I hope I am clear. Okay, and if you have any doubt or if you don't understand anything, please feel free to comment it down. All right. Now coming to question number 14. So which statement is correct for the muscle contraction? So in a row I am talking only about the muscle contraction so that we are staying in the flow. Okay. Now see, we are talking about the muscle contraction. So earlier I told you that how the muscle proteins are arranged, isn't it? Now let us see that how they are contracting. So see, this is the muscle in the relaxed state, and in the relaxed state the H zone is present, then it is the thick filament, it is the thin filament. All right, once there is action potential that is generated, then what will happen? The electricity will pass through all of the skeletal muscle, and once the electricity is passed, what will happen? The calcium will be released from the sarcoplasmic reticulum. Okay, each and every word in which the sarco is attached, it means that we are talking about the skeletal muscle. Okay, then this sarcoplasm will attach, the calcium will be released and the contraction will occur. In the contraction, the actin filament is coming towards each other. They are coming towards the center. And I told you that in the earlier question also, the actin and myosin, they always remain constant. They do not shorten. It is the distance in between the band that is shortening. And that is why the H zone reduced. See, there is no H zone at all. Then the I band. So what is happening to the I band? I band is still the same, isn't it? It is not changing at all. And what about the A band? A band is here and A band here. Is there any difference? No. A band is still the same. And the length of the 2Z line, the length of the 2Z line, it is same. Okay, mind it, the length of 2Z line, it is the same. It is the distance in between the 2Z line that decreases, and that is why, as the Trisha said, it is option B. Alright, it is most very frequently asked in the examination. Now coming to question number 15. The number of the cervical vertebra, option A, it is more than that of the rabbit. Option B, it is less than that of the rabbit. Option C, it is same as that of the whale. And option D, it is more than that of the horse. So see, actually you might be thinking that why am I talking about the camel over here, isn't it? But the NCRT and the people who are making the question, they are really very smart. Although about the camel and about the rabbit, it is not given in the NCRT, but there is one statement that is given in the NCRT, and that is, in all the mammals, the number of the cervical vertebra, that is same. Okay, whether you are talking about a dog or a human or any mammals, okay, all of them will be having the same number of cervical vertebra. And camel, yes, camel is a mammal. Okay, now talking about this, the rabbit, whale and horse, all three are mammal, and that is why the number of vertebra in both this animal has to be same. And hence, what will be the correct answer for this question? Yes, anyone? The correct answer for this question is option C. Alright, it is option C, that is whale, because in the mammals 7 cervical vertebra will be present in all of them. And you may say that camel is having long neck, and that is why the number of vertebra should be more, isn't it? But that is absolutely wrong. It is the size of the vertebra that is more. Okay, like it is the vertebra of the camel and it is the vertebra of the human being. Okay, it is more in size, but it is not more in number, and it is always 7 in all the mammal. So yes, Jivita, very well said. It is option C. It is same as that of the whale. Now coming to question number 16. Stimulation of a muscle fiber by a motor neuron occurs at option A, the neuromuscular junction, option B, the transverse tubules, option C, the myofibril, and option D, the sarcoplasmic reticulum. So I told you that the skeletal muscles, they are the voluntary muscle. It means that you can contract the muscle if you want, isn't it? But how do the brain control this muscle? It is via neurons or the nerves. So each and every muscle fiber, it is connected with a nerve fiber is connected with a motor neuron. So this is the skeletal muscle and it is connected with a nerve fiber, and this area, so this is the nerve fiber, and this area is known as the neuromuscular junction. So once the brain sends the signal, what happens? The brain sends this signal, and then the electrical activity sent by the brain, it is traveled through the whole muscle, and where this stimulation is occurring, at which area the stimulation is occurring? It is occurring at the neuromuscular junction. Yes, Jivita, very well said. It is option A, neuromuscular junction. Now coming to question number 17. Which one of the following is correct pairing of the body part and the kind of muscle tissue that moves it? Option A, biceps of the upper arm. Then it is saying that there the smooth muscle is present. Option B, abdominal wall, smooth muscle is present. Option C, iris, involuntary smooth muscle is present. And option D, heart wall, here involuntary striated muscle is present. So let us see what is the correct answer. So see what happens. First, talking about the biceps. So I told you about the biceps, isn't it? So this muscle over here, it is the biceps muscle, and I can move this muscle. Okay, and so tell me what kind of muscle it is. It is the striated muscle. It is not the smooth muscle. Talking about the abdominal wall. So you know, many people try to hide their tummy, isn't it? And that is why they are doing it on their own will, and hence it is not the smooth muscle. They are doing it consciously. They are trying to look slim. Okay, and hence option B is also incorrect. Now we don't know about the iris, but we know about the heart wall. I told you about the heart wall, isn't it? Yes, it is involuntary. We cannot control the heart, and it is striated or unstriated. We have discussed it earlier also. The heart muscle share the property of both the smooth muscle and the skeletal muscle. So like the smooth muscle, the heart is involuntary, okay, accepted. And like the skeletal muscle, it is striated, okay, it is not unstriated. And that is why option D is also incorrect. So the correct answer is option C. The iris has involuntary muscle and that is controlled by the autonomic nervous system. So the correct answer is option C. Here Jivita, it is option C. Now moving on to question number 18. Which of the following are the regulatory protein in the muscle contraction? Option A, troponin and tropomyosin. Option B, troponin and actin. Option C, myosin and the tropomyosin. And option D, actin and the tropomyosin. So here we are talking about the regulatory protein. So yes, Jivita, you are saying it's option A. Okay, let's see. I told you if the question was what is the contractile protein, so tell me what would have been the option. Okay, just comment it down. So see, there are two types of protein I told you, and they are the actin. So this is the actin, okay, and the other one is myosin. I talked about the myosin in the earlier question, so we have covered it. Now let us see about the actin. So it has this F protein, it is the F protein, and here it is the tropomyosin. It is like a thread, and attached to the tropomyosin is a small okay protein dispersed, and that is known as the troponin. The troponin is attached to the tropomyosin. Troponin has three units and they are TPI, TPC and TPT. TPI, it inhibits actin myosin binding. So the area where the troponin binds to the actin is TPI. Now talking about the TPC, it is C. C stands for calcium. This TPC is the area where the calcium binds when it is released by the sarcoplasmic reticulum. And talking about the TPT, so T stands for tropomyosin. So this area, it is the region from where the troponin binds to the tropomyosin. So whenever the TPC binds with the calcium, there is some conformational change, and because of that the tropomyosin is displaced from this area because of the troponin, and hence the troponin and tropomyosin, that is the protein that regulate whether the muscle will contract or not, and hence the correct answer would be option A, as the Jivita correctly said it. Now coming to question number 19. Which of the following is not applicable to the red muscle fibers when compared to the white muscle fibers? Option A, sustained contraction for longer periods. Option B, it is rich in myoglobin. Option C, faster in the contraction rate. And option D, it is rich in the mitochondria. So we are talking about the red muscle fibers. So there are two kinds of muscle fibers that is seen in our body, and they are the red muscle fiber and the other one is the white muscle fiber, and these names are based on the color that is present on them. So the red muscle fibers had a lot of protein, and that protein is known as the myoglobin. Okay, it contains the heme protein. It is similar to the heme protein, and that is why the color is red of the red muscle fibers, whereas the amount of myoglobin is very less in the white muscle fiber. And what is the function of the myoglobin? It stores the oxygen, and that is why whenever there is need for the contraction, some muscles require to contract, at that time the myoglobin releases the oxygen and the ATP is produced by the, which kind of oxidation will occur here? It will be the aerobic oxidation. And in the white muscle fibers the myoglobin is less, and tell me A is incorrect. So yes, Deepak Saran, please elaborate, what do you want to say? Okay, so see, in the red muscle fiber, myoglobin is present and it releases the oxygen, and because of that here the aerobic oxidation occur, isn't it? In the white muscle fiber, myoglobin is very less, and that is why the type of oxidation that occurs is the anaerobic oxidation. And if there is aerobic oxidation, where the aerobic oxidation occurs, it occurs, okay, it's okay, Trisha. Let us see. If the where the aerobic oxidation occurs, it occurs in the mitochondria, and that is why the red muscle fibers should have high number of the mitochondria, and it has the less number of mitochondria, but it has high number of other organelle, and that is the endoplasmic reticulum. All right, and where this red muscle fibers is present, it is present like in the back region. It is present in the back region. It helps you to straight up, and it is also present in the wings of the birds. So we need to maintain the posture, and the bird also need to fly for the longer period. Okay, and that is why the yes, it is present, so that the sustained contraction should be present. Okay, now it is rich in myoglobin. Yes, I told you. Now coming to the mitochondria, I explained you that aerobic oxidation has to be done, and that is why it is high mitochondria. Here the contraction rate should not need to be faster. The contraction rate in the red muscle fiber is low contraction rate, whereas the contraction rate is higher in the white muscle fiber. So the correct answer is option C, as the Jivita correctly pointed it out. Now coming to question number 20. What would happen if the ATP suddenly were not available after the sarcomere had started to shorten? Option A, cross bridge would not be able to detach from the actin. Option B, muscle would remain in a state of rigidity. Option C, muscle would relax immediately. And option D, both 1 and 2. So actually it is an interesting phenomena that is occurring in the muscle protein. So let us see. Actually, here it is the actin protein, and below the actin protein, the one that is sandwiched in between the actin protein, it is the myosin protein. So what happens is that whenever the myosin has to bind to the actin, it has to be bind. Okay, it has to be bound to the myosin. But the reverse is also true. Whenever this myosin has to detach, when it has to detach from the actin, and at that area, at that time also ATP is required. And why it is important, and that is why the cross bridge will not be able to detach if the ATP is not available. So option A is correct. Now see what happens when a person dies. When the person dies, then also you are dead from the brain. Dead means brain death in the medical literature. So when a person dies, the brain is dead, but the cells are still active. Your body is still active, and that is why the body is still utilizing the ATP, and the muscles are also are in the little bit of contracted state. Okay, they are still in the contracted relaxed state, but then suddenly with time the ATP goes off. ATP is consumed by the body, and then there is no ATP left to relax this muscle, and that is why the muscle stays in the contracted state, and that is why the dead bodies, they are in the rigid state or the contracted state. So the option B is also correct, and the muscle would not relax, it will contract, and hence it will not contract, I mean to say that it will be in the rigid state. So the correct answer, as the Trisha correctly said, it is option D, both 1 and 2. Now coming to question number 21. Bones formed by the ossification of tendon is called. So there are various kind of bones that are formed by the various ossification. So the major bones in the body, they are formed by the cartilaginous ossification. When we were a small child inside the womb, we were totally made up of the cartilage. When we were born, then gradually the cartilage ossifies. The cartilage ossifies. It means the calcium is deposited in the cartilage, and after that the bone is formed. Okay, clear. But there is other mechanism also by which the bones is formed. And what is that? There are various type of bones that is present in the body. Okay, Jivita is saying that it's option A. It is sesamoid bone. So let's see. The sesamoid bones are the bones that is formed by the ossification of the tendon. It is formed by the ossification of the tendon. So yes, and the example is patella bone. It is present in the lower limb. The second kind of bone is the cartilage bone or the replacing bone. It is formed by the pre-existing cartilage, that is the humerus and the femur. Okay, and option D is the investing bone. It is formed in the dermis of the skin and then it fuses to the original cartilage. So yes, the correct answer is Deepak, very well said. It is option A, that is the sesamoid bone. Now coming to question number 22. Total number of bone in the appendicular skeleton of the human is option A 126, option B 80, option C 44 and option D 33. So what is the correct answer? Actually, the total number of bones that is present, it is also asked the total number of bones in the appendicular skeleton and also the axial skeleton. The value of the bones in the axial skeleton, it is given in the NCRT, and the total bones is also given in the NCRT. So you have to do